Hello. Okay, you should see the desktop. You should be able to hear me now. Does everything seem to be working okay?
Yeah.
Yeah?
Yeah.
Okay, great. Thank you. Let me just get stuff set up. Okay. Okay. Let's see. So first, one thing at a time. Anybody any question about the homework assignment?
Yeah.
Mm-hmm.
So I was having problems with I think my program is right, but I'm trying to test it with the test case. The test case is as it like tells you in the assignment description.
Uh-huh.
And hold on, I'm gonna see if I can try to pull it up again. But it says like in the blank space in homework 3, you have to right click shift or shift right click, right?
Uh-huh.
And the only thing I have, it doesn't list the command prompt. It doesn't say like open command prompt window
Does
here.
it say open PowerShell here?
Yeah.
Oh, that's okay. See, you can see my look at my desktop. If I shift right click, I have both of them. Open command window here and open PowerShell.
Okay.
So probably the newer versions of Windows only have the PowerShell one.
Okay.
Yeah, that makes it messier. Okay. Here's something. You should just be able to double click on this file.
I'm not able to because Windows blocks it, but it says.
Okay. There's nothing dangerous about it. Click more information, run anyway.
Oh, I didn't even see that.
Yeah, and it'll never ask you. Now watch, it won't ask me that question again. If I do it again, it won't ask me that again. It's Windows has become so afraid of everything. So I can't even make that happen again. But there's that little more information button. Click on it, and then you can click on run anyway.
Okay.
And then your program will run in this window, and your output should look like that one. So your output in the window should look like this file here.
Yeah.
Now, I don't have the program written, so I just got no output. I got error. Okay. Did it run when you double clicked it?
Yeah, it looks fine.
Okay. Yeah, and then that little program, which you can edit it and you can see what it looks like. It's just.
Why does it have? Oh, sorry.
What? Go ahead.
Why does it have 2 S's? Line has a lot of spaces.
Oh, I thought I fixed that.
Is that a typo or is that how
I thought I fixed that. Oh, I fixed it. Yeah, I fixed it, and see, yeah, you have an older I fixed it. Yeah, so you have it. You probably downloaded it a few days ago, and it was a typo that I fixed last night.
Okay.
Yeah.
So if mine if mine outputs 1 S, is that okay then?
Yeah. Because that was a typo in that file.
Okay.
That was a typo in this file. That if you download that zip file again and get this file out of it, it'll be better. I fixed one typo in this file here.
Okay.
Okay. Yeah. So that was a typo that was in this test script output file. Okay. So for everybody, that's actually a better point, that since Windows has changed and you don't have that open command window here, you have this open. Now Windows just has open PowerShell window here. PowerShell doesn't work the same way, and you can make it work the same way. You type CMD there, and now it's not a PowerShell. Now it's a CMD window, and then you can type this run test script. Okay, see, and that that output should look like that output. The trouble with PowerShell, let me just show you. Let me start it over again. Microsoft keeps making this stuff more and more confusing. If you do run PowerShell, then you try to say run test script. It doesn't work in PowerShell. The run test script won't work in PowerShell. And Microsoft, it's just, they keep changing things, and it's not always for the better. It makes things kind of tough on people. It's one reason why people like Linux. Linux is not being changed constantly. Okay, so now again, if you do open PowerShell and you want to try what I was talking about, then you have to switch it by typing CMD. You switch it to CMD, then you can type this run test script, and it runs. See, it won't run in PowerShell, but it will run in CMD. Okay, and PowerShell and CMD and what in Linux was called the Bash shell are really important. I mean, that's one of the things we're going to be teaching you more and more about. And I wanted you to see at least a little bit of using a test script that runs in a shell. But Windows just keeps making this stuff more and more messy. Okay, so if you just double click it, that's fine enough. Yeah, double click it and it'll run. Okay, and your output should look like that one. Okay, so you can just go ahead and do double clicking. But if your Windows computer complains about you double clicking on that, look for the little thing that says, what was it say? I can't remember now. What did it say? Run anyway? No, more information. Yeah, look, click the little button that says more information. Then it gives you a button that says run anyway. There's nothing dangerous about this. Okay. All right. Okay. More questions about homework. Anybody have other questions about the homework assignment? Anything else? Some people have written to me asking if you could do this assignment using for loops and if statements. We haven't talked about for loops. We haven't talked about if statements. And it's actually a bad idea to do this assignment with for loops or if statements. I guarantee if you write this assignment using for loops and if statements, you're doing it wrong. Okay, this assignment is way easier than that. The key to this assignment is to use what's in the string class. You'll write way less code. The code will be way easier to read if you do it using the string class. If you write code with for loops or if statements, you're heading in the wrong direction. Now, we haven't talked about for loops yet, and we've only briefly talked about if statements. They don't help in this assignment. You'll be doing things in a more complicated, convoluted way. You won't be solving it the good way. Okay, you'll end up with code that isn't good. You'll end up with a solution that people would criticize because it'll be over. It will be in the wrong direction. You only need to use methods in the string class. So all the work is going to be done by the string class for you. Remember, we said you look through here and you look for methods you can use. Things like to uppercase, that's there for you. And substring is there for you. It gets parts of the string. There's two versions of substring. One version that says start and end in a certain place, and another version just says start and go all the way to the end. So that's a more convenient. Sometimes that's more convenient than this one. It just says where to start and it goes all the way to the end of the string. This trim command is real useful. It'll remove extra spaces that you maybe don't want. See, like in this example, it'll take all the spaces that are in front of the Java. It takes all. Well, I can't highlight them. It doesn't. It takes all these spaces here and all these spaces here and removes them. So you end up with just the stuff that's in between. What they don't show you is it doesn't remove spaces that are in between. It only removes spaces from the beginning and the end. So if there were spaces in between the J and the A, it wouldn't remove those. Okay, so it trims from the ends. So you look for things in here that you can use. So you should be writing the assignment as just string variables with calls to string methods on string variables. You need to create a lot of string variables, and you need to call several methods on those string variables. That's the goal of the assignment. Okay? And you can write a for loop to do this, but you'll end up with something that's longer and more complicated than it should be. And you should be writing even if you know that kind of stuff, you should be writing the simple solution. Every programmer wants to write the simple solution to a problem, not the complicated solution. So it isn't good to use a for loop or if statements in here because those are more complicated. It can be done without them. So if you can do it without them my solution to this problem is only 10 lines of code. And most people who've solved it, I think people are usually running around 10 or 12 lines of code. There are people who've submitted it or asked me questions and showed me what they work. Most of the people who are getting it in anywhere from 10 to 15 lines of code. Okay, so it doesn't need to be very much, but it is a little bit tricky. It's not, it's not easy. You have to read these and think about how you could use them to manipulate string and create new variables to have the parts you need and then put things back together again. Okay, so make sure you're doing it using string methods. Okay, other questions? Anybody else got a question about the assignment? Okay. Okay, so make sure you run the tests. Make sure you run the tests. If you can't get that test script to work, like if you're on a Macintosh, you can always just open each one of these files and see what the test is. You can see what the test is, and you can open this one, and you can see what the answer should be. So the first test had the answer is the language Java, okay? And then like the second test, the answer to this one was the second answer. Line is space funny this, okay? So this one got converted to that one. So if for some reason you can't get the test to run automatically, you can still type these lines into your doc. You can type each of these lines. You can copy and paste one of these lines from there into Dr. Java, run your code with that input and make sure that it looks like that output. Then you can go to the next one. You could copy and paste. At the worst case, you can copy and paste that input into Dr. Java. There's all the space at the end that you don't see it, but you can see when you highlight this thing. See, the highlighting stops there. There's all these spaces at the end. So you can copy and paste that into Dr. Java and test it, and you should get out this one. Okay. So if you can't run the automated, the script that runs the test, you can still check your program on these tests. So make sure you test your program that it works at least on, and write your own test. Once you got your program writing, type your own sentences. Try to see if you can get your program to get you what you think is the wrong answer. I mean, the whole point of testing is you're trying to make your program do something wrong. It's counterintuitive. You want your program to be right, but when you test your program, you're trying to convince yourself that it doesn't do anything wrong. So you're trying to think of things that'll make it do something wrong. Okay, so you just try lots of different cases. Okay, all right. Next is, remember there'll be this midterm on Thursday, and here are the review problems. Anybody have any questions about this stuff?
So is the test you said it's going to be handwritten?
Well, yeah.
Like optionally?
Well, if you want to type it, like you can do it in Word. Word would actually be not a bad place to do it. You could do it, you could type it in Dr. Java, but that would be kind of hard. Like some of the problems ask you to draw a little picture, like draw a memory diagram, like the Java visualizer does. That would be kind of hard to do. I mean, you could do that in Dr. Java. It'd be a little bit hard to do. You could do that in Word. Word will let you draw little pictures because you just need to be able to draw little boxes. If you just do it with paper and pencil, that might be the easiest way to do it, but then you have to scan your answer in. If you do it in Word, you don't have to scan anything. You can just upload your Word document to Brightspace. My single requirement is that I can read it. Yeah. And I don't want, it should be one document that I can read. So if you scan your if you write the homework problem on pieces of paper and you send me 6 pictures of pieces of paper, that's not acceptable. And I can't have 80 people sending me 5 and 6 pages of it just becomes unmanageable. So you should send me one document. It can be a PDF file of your pages. There are cell phone apps you can snap pictures of pages, and a cell phone app will bundle them into a PDF. I think, I can't remember if I showed you guys this one, but a well-known one is Adobe Scan. Okay. Okay. And I think iPhones have something built in. I don't think Androids have anything built in that'll do this. But like the Adobe Scan will let you take snapshots of pages, and it'll bundle them into one PDF. So you can just use your phone camera to take pictures, and then it does the work of bundling them into a single PDF. And then you can upload that to Brightspace. Okay, so what you turn into me should be readable and one document. If you want to make it in Word, that's good. You'll be downloading from me essentially like what looks like a regular test. It'll be like 6 or 7 pages with a problem per page with space for you to answer the problem. If you can print that out and write your answers on that and scan it back in, that might be the easiest way. If you don't have a printer, you can copy and paste the problems into Word and answer them in Word, for example. Okay, so if you're good at working with some program like Word or PowerPoint, if you're good at using something to create documents, that's fine. If you want,
is there gonna be a time limit?
yeah, but the time limit will be like you have all evening, so it'll be due by midnight. Okay.
And when does it open?
Right around when class ends. So we'll have class, and then it'll open right after class. You have all evening to do it.
Okay.
So the exam will be, we'll have class, and if anybody's got any last minute questions, we can talk about this stuff again in class on Thursday, and then you'll have the whole evening after class. And it's meant to be about a 1-hour exam. I mean, it's real similar to it'll be very similar to the exam I gave in class when we weren't, all stuck at home. And it's a 1-hour exam. Okay. So
is there any particular way you recommend us prepare it? Like any particular way you recommend we prepare for it?
Solve each of these problems using the Java Visualizer. Oh, where did it go? Solve these problems and use the Java Visualizer to see yourself solve them. Like,
Okay.
if this thing, like this one's missing a couple lines. This one's missing some code right here. So copy and Java Visualizer. Use the Java Visualizer for as much as possible. Okay, now there's something missing there. Okay. And you can just type the code in here. Now on the exam, you would just write, if this was an exam problem, you could just write on the page your couple lines of code there. You can just write them in pen or ink, you just write it with your pencil what you think is the lines of code there. But in this case, you could then test it. You can make sure you have the right answer. Okay, like right now, this thing doesn't do anything because the code's not there. Okay. Okay. So you have to. The problem was to get this output, to fill in the missing thing here to get that output. Okay. This method looks like it's going to do that part of the output. See? And you look at here, and this looks like it does the pop part. So like over here, you can say, okay, method, what's it called? B. Method B seems to do the top part. Method A does the bottom part. What did I do wrong? It's spelled. If you don't want to step through your code, you can just go to the last step. Okay. Okay. That's not quite the right output. Now it's missing this stuff here. And so solve the problems using the Java Visualizer. The nice thing about the Java Visualizer, it lets you see that you're doing the right thing. You could try things and try things right in the visualizer, and that's what I always tell students is to go to use the Java Visualizer to work on these problems. Okay, like another example is like this one. What are the values of the following expressions? Well, you can check yourself. Like, what's the value of this thing? Well, copy it and go over to the Java Visualizer. Okay, and just put it in the Java Visualizer. Okay, now there's that one line. The question was, what's the value of this? Okay, so I want to visualize line 21. I want to see what happens when line 21 is executed. Okay. Oh, I forgot to say see, I need that piece there. See, the visualizer, you have to go kind of go a little bit back and forth. So there's what S is. Now what's this thing do? Okay, now I'm going to find out that I'm not doing something. Okay, there's S. I wanted to know what 22 did. How am I going to figure out what 22 did?
You can print it.
I have to print it. I either print it or I can. Now remember, what happened was that the Java computed this answer and threw it away. See, it computed the answer and threw it away. If you want to see an answer without it being thrown away, there's two ways you can see the answer. One is to print it. What's the other way?
Variable.
Pardon me?
You can make it a variable, right?
Save it in a variable. Like, okay, I'll save the answer in another variable. Okay, so I want to see what the answer is, so I'll say string t equal. Instead of printing it, I'll save it. Okay, now go over to Visualizer. Okay, there's S, there's T. Okay, then you think about it. Is that why was that why was that what it did? Okay, you should be able to explain why that's the answer. Okay, so these problems ask, what are the values? Okay, so what I'm really saying is, can you explain to me what that does? Can you explain to me what that does? Can you explain what that does? Okay, can you figure out what those things do? You can use Java Visualizer to do them, but then you should start and think, how did that work? Okay, what did this line of code do? Now go to what did this line of code do? Substring does what? So you have to explain. I ask you on an exam to explain what this does. So you start here. What does substring do?
It takes a part of the big string.
Pardon me?
It like takes a part of the big string.
Yeah, it takes the part of the string on the left. It finds a part of it. Now where it needs to know where to start and where to end, right? Here's where I start. Now, what is this saying? Where do I start my substring?
The first time E appears.
Yeah, first time. See, I say find the index of the first of E. Find the first index of E. That gives me a number, which I give the substring. So this finds the index of the first E, and then it says that number is where you start the substring. Where do I end my substring?
At the last index of E.
Yeah, so then you go up here and you say, okay, there's the first E. Now, here's a trick question. Where does my substring end? At which of those two E's?
If you print it, it will end at the first.
Why?
It's a good question.
What's the rule for substring? You give it a starting integer and an ending integer, but what's the catch?
Standing integer is not included.
Yeah, you don't count, you don't actually include the last, the ending index isn't part of the substring. Okay, so the last index of E was the index of that E here, but that's not considered part of the substring. So the substring will go E space TWO space THRE and stop there. The index is of the last E, but this index is not part of the substring. Okay, so you go over here and you see it stopped at THRE. So even though I said the last index of E, it did the right thing. The last index of E was the index of that E there, but the last index is not used in the substring. You go up to not including the last index. So starting at this index, up to, but not including this index. Okay, so you end up with E space TWO space THRE, and not the other E. Okay, so the idea is to go through this and use the Java visualizer to answer these questions. Okay, so that you can explain what these things are doing. Like here's another, let's try this one. What does that thing do? Okay, I just copied it. So I'm gonna copy, and now I'll go here and I'll say, okay, I want this other one. This is another one I'm gonna try. Now let's think about what it does first. It takes this, does what substring? So from 3 to 8, right? 0, 1, 2. There's character 3. It's the space between 1 and 2. There's character 3, 4, 5, 6, 7. There's character 8. Okay, so you go from character 3, which is this space, up to, but not including, character 8. Okay, so there's characters 3, 4, 5, 6, 7, not including 8. Okay, so that's what that thing gives me back. What does trim do?
Removes the spaces around it.
Yes, and this thing, I purposely kind of set it up so that it included a space just before at the beginning and a space at the end. So it removes those, and it gives me back that. Now, what does length do?
Counts the number of characters.
Yeah, on the thing that the trim gave you back. See, it's because I'm calling length on the thing that trim gave me. So I'm going to get 3. So the answer will be 3. Oh, and notice that I can't say string here because the answer is an int now. So I have to go, see, if I left that string, I'd get a compiler error. Because the compiler knows is that this thing on the right computes an integer. So you can't put it in a string. So I have to get the answer in doc, I have to change that. Now I'll have the answer in T. There's S, there's T's 3. Okay, so I saw that T is 3. Okay, so that's what this stuff is about. Is you're gonna show that you can read a line of code like that. Show that you can read a line of code like that. You know, show that you can read and follow the logic of a line of code like these. Okay. Yeah. So yeah. Like here's another one, a little bit more complicated one. Okay. Yeah. First, it finds a substring, makes it 2 uppercase. That's still a string. Then it adds on some other substring. The adding of 2 strings is in string. So the answer, now we're back to string. So the answer is going to be some string. And it'll be, okay, you know, you go through here and say, okay, it takes the original string and takes some part of it. 4 to 5, how many letters is that?
1.
1 letter. Yeah, because remember, it's starting at 4 and up to, but not including 5. So if you go up to, not including 5, you just got the letter at 4. So that's just a single letter turned to uppercase. Which letter is it? 0, 1, 2, 3, 4. Okay, so it's the T. So this capitalizes the T. Then it adds on 5 and 6. No, see, it goes 5, 6, but not including 7. So that's the T and that's the W and the O. So what this does is it pulls out the TWO and capitalizes it with the and capitalizes the T. Okay, very similar to something you would do in the homework assignment. So this pulls out the TWO but capitalizes the T. There, see, pulled out the TWO but capitalized. Actually, it pulled out the T in one step and capitalized it, and pulled out the WO and added it to the capitalized T. Okay, and you get TWO. Okay. Now, there's lots of, almost everything in here can be made into something you can try in the Java Visualizer. Okay. What about other problems from here? Anybody have questions about these problems? Are there any questions in these problems that we should try?
Can you try number 17? The if
17?
statement. Yeah.
Okay. So, all right. Okay. Here's the bulk of the code. So let's go here and put the, let's see. I'll clean this up a little bit. Okay. There's the code. Okay, there's the code. Okay, and let's see. Now they ask you two things. Give the output if this is true, or there's two cases. Okay, now let's go ahead and let's create these variables with those values. So we have to do that. So let's go up here now and say, okay, we need an int x equal to 1 and an int y equal to, what was it? Was it 1 also? Yeah, x and y are both 1. Okay, so we need to put that in there so that this can work. Now let's step through it. Before letting the visualizer step through it, let's step through it. If x is strictly greater than 1, we do what's inside here. But if this is false, we go down to here. So is this true or false?
False.
False. So I can ignore all this code and I'm now down here. Okay, so I'm down here. All right. So if this is true, you do what's in the if part. If it's false, ignore that and go to the next part. Okay, now I'm down here. Same kind of thing. If this is true, I print out this. But if it's false, I print out this. Okay, y greater than 2. Is that true or false?
False.
False. So that means I'm printing out this. So if my analysis is this should print out 1 plus 1 is 2. Okay. Now, how do I know? So that would be print out 2. Now, how do I know I got the right answer? Like, first of all, I could trace it. But what would this thing print out? If this was the printout, what would you see?
0.
1.
Yeah, 2 times 1 is 2, minus 1 would be, 2 minus 1 is 1. What would this one print out?
3.
3. What would this one print out?
0.
Yeah, so notice that the outputs would all be different. So if I see 2, I know it was this one. Okay, so now let's go ahead and visualize it. Oh, what'd I do? Misspelled. Oh, that misspelling's in the original, isn't it? That was, oh yeah, those misspellings, those typos are right in here. I have to clean that up. Okay. All right. So now, right now we can trace it. we said that this was false, which meant we were supposed to jump down to here. Yep, see, it jumped down to there because this was false. We said that this one's false, so we should jump down to here. Yep. Okay, and now it's going to print out 2. Okay. Now, the problem said, well, okay, analyze this code 2 ways, with this, and then do it again with this. So let's go back and do it again. Now make this 2, make this 2. But let's do it ourselves first. Oh, now these outputs will change. These aren't the right outputs. Okay. Is this true or false?
True.
True. So we're doing this block of code and we can forget about the rest. Is this true or false?
False.
False. So we're doing this one. Okay. Now in our case, this one is 2 times 2 is 4 plus 2 is 6. This one would be 2 times 2 is 4 minus 2 is 2. If we were down here, this one would give us out 0, and this one would give us out 4. So notice that they're all, I made it so that the outputs would all be different numbers. So if you only looked at the output, you could still figure out if it was this one, this one, this one, or this one. Okay. Now we just said that it should be this one. Okay. It should be 6. Now let's trace it. Make sure we analyzed it right. Yeah. Create the X and Y. Okay. This one's true. So we should be on line 10. Okay. And we'll never go down here now. Okay. Now this one's false. So we should go to line 13. Okay. And then we should get output of 6. Okay. All right. So, as eventually as programmers, you should be able to read that without the aid of Java Visualizer. But that's a goal. Yeah. You're not supposed to be at the goal at the beginning of the course. So the goal is to be able to read code like that and pretty much just see it in your head how it's working out. Trace through it like we just said. Oh, is this true or false? If it's true, I go to here. If it's false, I go to here. Is this true or false? If it's true, I go here. If it's false, I go here. So you can trace it out. Then once you know where you are, then you can say, okay, now let me figure out what that number evaluates to. Okay. What about another problem from here? Any other problem that would be good to try? Anybody else got a question about these problems here?
Just a question. What is number 18? Like,
Pardon me?
number 18.
Okay. Yeah.
After if statement W++, what are those?
Oh, they mean add 1 to this.
Oh, okay.
Yeah, we briefly did those. I mean, there's a lot going on in this stuff. If you go back to chapter 1, I think it was chapter 1 of the book. Let me just do it. It's because just in case anyone's forgotten where those were. Oh, it's chapter 2. I think it's in here. Oh, I'm trying to remember now where it was. Probably it's in the other book. They explained the ++ symbol. Just want to make sure I can find it. Does anybody remember offhand where the ++? I remember we did it. We looked at it real briefly. It's mentioned and used. Now I'm trying to remember. Oh, here it is. Incrementing the value of a variable. No? It's a shorthand for adding 1 to a number. It's a shorthand for that. No, it's not on this page. Where is it? See, now I've forgotten where we did it.
But isn't it plus an equal sign?
Pardon me?
Like for adding 1 to the value, isn't it plus and another equal sign? If I remember.
I'm sorry, say again? There's 3 ways you can add a 1. Yeah, see here, see, it's mentioned here. There's 3 ways you can add 1 to a variable. And it's just kind of one of the messy things. Let me show you real quick. 3 ways to add 1 to x. X equals x plus 1. That's one way to add 1 to x. X plus plus. Actually, there's also plus plus x. That's another way. And then there's x plus equal 1. So this adds 1 to x, adds 1 to x, adds 1 to x, adds 1 to x. There's these 4 different ways to add 1 to x. Programmers use this one a lot. Okay, so x is going to go from 2 to 3. The next is going to go from 3 to 4. Now it's going to go from 4 to 5. Now it's going to go from 5 to 6. Okay, this means add 1 to x. This means add 1 to x. This means add 1 to x. And this says add 1 to x and then store the answer in x. So this is the kind of the long way to write it. The right-hand side says add 1 to x. Then the left-hand side says store the answer in x. I mean, I could store the answer in y. Yeah. So the thing here is this could have been stored in y. It adds 1 to x, but puts the answer in y. This automatically updates x. These 3 automatically update x. This one adds 1 to x, but it leaves you to decide where to put it. So here it puts it in y, or you could put it back in x. Okay, so in the review problem, these mean just add 1 to x. This is where C++ gets its name, the language C++, because it's adding a little bit to the language C. So this was adding 1 to W, C++ is adding something to C. That's what there was a joke. When they created the name C++, they were actually creating a joke. Okay, now this is an interesting problem. We go over here. Here's how you're supposed to think of it. Somewhere in your program, there's a U and a V, but you don't know what values they have. Okay, and then you get down to this 3 lines of code here. And the question is, when these codes are done, what's in F? If you print F, W, what's in it? What can you say about what's in W? Okay. Let's just think about it here. You start with W0. You don't know what's in U, but what is this line saying? You can still read it, even though you don't know what's in U. What is this line saying to you? This line has a meaning. You don't have to know what's in U to say what this line means. So yeah, so tell me, what does that line 10, what does it do? What does it mean?
if u is greater than 0, so you're gonna add 1 to w.
Okay, so yeah, you can. I mean, if you just read it, it says if u is greater than 0. So what? So in if you were talking to somebody, what is this doing? What is u greater than 0 checking? It's checking if you have a positive number, right? It's just saying if u is positive. If u is positive, add 1 to w. So now w is 1. What does this guy do? So, yeah, go ahead and you can unmute yourself and talk because it's good to just the idea is that we'll see there's a real nice answer to what this code does. What does that line by itself do?
If v is positive number, add 1 to w.
Okay, so if v is a positive number, add 1 to w. Okay, come down here and tell me what does w mean. Think about it. It's telling me something about u and v.
Would it still be 0? Because it is neither positive nor negative.
Pardon me? Okay, every one of these u and v is either a positive or negative number, right? Every number has to either be positive or negative. If u is positive, add 1 to w. If v is positive, add 1 to w. Tell me what I've got in w. I've got something interesting in w.
Does it tell you if one or both are positive or neither?
So here's another, yeah, but put it even more succinctly than that. What is w doing? This is how programmers think. W's got an answer in it, and it's done something that's a little bit interesting. It did say, I'll tell you what, give you a hint. It counted something. What did it count?
The number of positive or negative
No,
variables.
no. It counted the number of,
Or the number of positive variables.
yeah, it counted the number of positive variables for me. If it's one of those is positive. Don't know which one, but if it's 2, they're both positive. If it's 0, they're both negative. It's a clever way of counting how many of them were positive. That's actually a useful thing. I've got 2 variables. I don't know what their values are, but I can tell you that this little piece of code does something interesting. It stores in W a count of how many of these are positive. And the answer is either 1 or 2 or 0. Okay, so because each time I get a positive one, I add to the count. If this one's a positive one, I add to the count. So down here, I've now got a counter that counted how many of them are positive. Notice that this funny little thing is actually a calculation. It's a calculation that you can give a name to. It's saying, I've got a bunch of variables. I want to know how many of them are positive. I don't care which one are positive. Down here, I just know that either they're both negative. One of them is positive and the other is negative, or they're both positive. So the answer here is 0, 1. W is 0, 1, or 2. Those are the only possible answers. W is 0, 1, or 2. And what it's doing is it's telling me how many of my variables are positive. 0 if they're both negative, 1 if one of them is positive, and 2 if they're both positive. I never have to tell you what U and V are to tell you what this code does. Okay, so that's what's interesting. You can figure out what, now, the reason that could be interesting is I could then turn this into a method. Later on, I could say something like, I've written a method that might be useful. then I would have to say, okay. This method takes in two numbers and decides how many of them are positive, okay? If you give this function two negative numbers, it'll return 0. If you give it one positive and one negative number, it'll return 1. If you give it two positive numbers, it'll return 2. So it counts how many of these are positive. And notice that I can tell you what that method does without knowing what U and V are. See, that's the idea, is that this does a calculation, and I don't need to know what U and V are to say what calculation it does. It takes two numbers and it essentially counts how many of the two are positive. And I can make this take three numbers and do this with three numbers. So I don't need to know what U and V are. See, here they're inputs to a method. So who knows what somebody's going to give me here. But what I really care about is, are they positive numbers or not? If they're positive, I count them, and then I return the count. And if I wanted to make this easier to understand, I might even call that count. Start the counter at 0. Increment the counter if one of them is positive. Increment the counter if the other one is positive, and return the counter. Yeah, change the name from W to count, and it becomes a little bit easier to understand it. All right. So so that's what this problem is about. That's actually a little calculation that's kind of useful. It counts how many, it's counting how many of U and V is a positive one. Do you have two positives, one positive, or no positives? Okay. And what's important is that you can analyze code like this without knowing what the U is and without knowing what V is, because it's really asking you, what does this do for any possible U and V? What is it doing with the U and V? Okay. And these other ones are similar. They don't have nice, the other like this one does something real similar. You can think about this one. It's a little bit different. Try to see, if my memory is that this one, you can figure out what it does. Okay, think of this as a counter. Okay, what's this one do?
If U is greater than 0, it adds 1 to
Yeah.
X.
Okay, but then it does what? This is an if statement. So after it adds 1 to X, what happens next?
Prints out. Well,
Prints out.
the
You just skip-
variable's wrong, but yeah.
Yeah. Pardon me? Oh, well, yeah. Then we would want to print X on here. Okay, and these answers could be different. Okay. All right, so you start with this X is 0. If you got a positive U, X becomes 1, but then you don't do anything else. Okay. What if you got a negative U? What if this is false?
Then it skipped down, but it would check if V is greater than U or not.
They'll check if V is greater than 0. If V is positive, then you get add 1. How many different values can X have? X is, can we go? See it. How many things can X hold here?
It can be 0 or 1.
0. Oh, yeah. No, say we see why it's 0 or 1. Can I get 2 out of this? I mean, there's an X plus plus and an X plus plus. Why can't I get 2? There's an X plus plus. There's an X plus plus. Why don't I potentially get or 2 here?
Because it's if else.
Yeah. So that means what? You have to, you have to imagine, you have to explain this. You've got somebody who just keeps asking you, like me, like explain, explain, explain. And you got to be able to explain. So there's a plus plus and there's a plus plus. So why can't I get 2? They're in an if. but that means what?
If one is true, we skip the bottom.
Yeah, you always skip one half of the if. If this is true, you do that half and skip that one. If this is false, you skip that one and go down there. Okay, now, but how do I get 0 out of this? Remember, we said it's 0 or 1. Well, but here it looks like I'm going to do this or this, right? So I would always have 1. How do I get the 0? Why is it 0 or 1?
If they're both false, then the value of x
Yeah,
doesn't
Because
change.
if this is false, you skip that one. But if this one's false, you skip that one and you've made no change to x, so you could still be at 0. Okay. Can anybody tell me what x is answering? What question is x answering?
If there is a positive,
Yeah, it's asking the question, is one of them positive? Is one of them positive? The answer is either yes or no. Yeah, well, actually, yes or no. If one of them or both of them is positive, yeah, if both of them are positive, you'll still get 1 as the answer. But x is now the answer to the question, is one of them positive? If x is 0, neither of them are positive. If x is 1, one of them is positive. So this is actually doing a clever little calculation. It's storing in x the answer to a question. Is one of the two numbers u and v positive? Okay. This one answered the question of how many of u and v is positive, 0, 1, or 2. This asks the question, is one of them, I don't care which one of them, is one of them positive? Maybe both of them are positive. And then it just gives me a 0 or 1 answer. 0 means neither one are positive. 1 means, yeah, one of them is positive. At least one of them is positive. Okay, so see, so you can analyze this code without somebody having to tell you what u and v are. The code itself makes sense. It won't run. This thing won't run because I didn't give u and v values. Okay, yeah, but that doesn't mean I can't answer questions about this one and answer questions about that one. Okay, and this is the kind of thing that this is thinking about code. This is, I mean, like, if you think of it, this is 3 lines of code. 3 lines of code shouldn't be hard, and it would be nice to say to the world that 3 lines of code isn't hard. But once you learn programming, you realize that 3 lines of code can be really hard. It'll always be the case, no matter how much you've learned about programming, that I can write 3 lines of code that'll be hard for you to read. Okay, this 3 lines of code is hard for you to read now. After a while, it won't be. But I'll write 3 more lines of code, and it'll be hard for. I can always write 3 lines of code, no matter how much you know about programming. I can write 3 lines of code that are hard for you to read. I can write 2 lines of code that are hard for you to read. It's amazing how much complexity you can put into a little bit of logic, because logic is hard. So you're starting, but your goal right now is to be able to read that 3 lines or to read that 5 lines and say what it does. You start with simple examples like this, they're not trivial. It's not trivial to say, oh, this thing is counting the number of positive numbers. This thing's telling me if one or both of the numbers, it's telling me yes or no, essentially. Yes or no, one of them is positive. Okay. But by thinking about it and studying it real carefully, you can step through the code and say, well, it does this, when this is positive, I get a 1 here. But if this is not positive, I go down here and check if this is positive. Well, if this is positive, but then I'll have a 1 here. So I end up with a 1 if one of them is positive. And the only way I get 0 is if this one's not positive and this one's not positive. I skip both of the pluses, so I end up with 0 if they're both negative. So it's telling me if one of them is positive. Okay, those are tricky problems. That's non-trivial thinking about a small amount of code. Okay, all right. What other questions? Other ones from the other problems like these? Any ones like these? Every one of these you can do in the Java visualizer. Like here, if I really want to check this, I can go like let's see. See, I can check W. W is 0 or 1 or 2. 0 and X is 0 or 1. Yeah. And so now it'll visualize. No, let's see, what did I forget? Oh, semicolon, semicolon. Yeah. And W is 2 because W counted how many of them were positive, and X is 1 because it only told me if one of them is positive or not. And then I can go play games. I can say, see, both W is 0 because I was counting the positives. There's no positives. And X is 0 because it tells me if one of them are positive or not. So let's go back and do one more case. 1 positive, 1 negative. Okay. W is 1 because it counted how many of them are positive. And X is 1 because it's telling me that at least one of them is positive. Okay, so you can verify that these things are doing. You notice it's much more interesting to think about. In this case, running it is much less interesting than thinking about it. You know, because running it only lets you check one pair of numbers at a time. When you think about it, you're actually thinking about it for all possible inputs. You're really thinking, oh, W 0, 1, or 2, where it's counting how many of these are positive. Yeah, X is 0 and 1, 0 meaning neither of them are positive, 1 meaning at least one of them is positive. Okay, so you can run the code, but this is one of the examples where actually running the code is a little bit less interesting than just thinking about the code. Okay, all right. Now, the next thing to talk about in the class, it's not going to be on the exam, is a little bit more about logic. So we'll be talking more about this after the exam. Okay, where is it? We really want to talk, a real important thing is to talk about these and or and not. These are called the logical operators. We actually can build up all kinds of programs are built up by very complicated combinations of ands, ors, or nots. You ask questions in programs mostly by using a combination of ands, ors, and nots. And you know, you can imagine, like, when does this, you know, I think, when does a customer get a discount? If the customer is registered with in your program and they have a coupon, or something like that, you get a discount if you have a coupon or you're over 65. Yeah. If you think about it, lots of things are decided by ands and ors. Okay. And what we want to do is start talking about the actual details of ands and ors, because we're going to see that and or in programming are a little bit different than and or in English. You know, this and is actually not the and of English, and this or is not quite the or of English. They're close, but they're not quite the same thing. And in Java, you don't write the word and, you put 2 ampersands to mean and in Java, you use 2 vertical bars to mean or, which is really weird. Like, you know, why did they choose 2 vertical bars? Why didn't they just have you write or? Why didn't they just have you write and? I actually don't know why they didn't do that. Many programming languages, you write and or. See here, you write that instead of saying clean room and did homework. Okay, you read it, clean room and did homework. Okay. And I don't know why we actually use these funny little symbols, but we do. Okay. And there's quite a few programming languages where you would just write there, you know, you would actually write and, which would be a lot easier to read. Or you could write or, okay, but not in Java. Okay. Okay. Now here, the idea is that, you know, when can you go out, you know, after you clean a room and do homework? Okay, so you have to do both of them. And means you have to do both of them. Okay, and that's pretty much what it means in English. It's actually the or that's got, it's the or in programming is the one that's a little bit more not like the or in English. The or in programming is a little bit more not like the or in English. The and in Java is pretty close to what we think of as and. You need this to be true and you need this to be true. Okay, so in this case, if this is true and this is false, this one wants true and true to be true. So in this case, if you like run this, you can't see the answer is you can't go out because clean room was true, but did homework was false. You didn't meet both conditions. Okay. Now, or means one condition. Did you clean your room or did you do your homework? So you get rewarded if you did at least one of those two things. Okay. Or would mean you had to do one of the two. You need one of these to be true. Okay. So if you run it now, see, you can go out. Okay. Because you have one of these true. Now here's where or is kind of different. Suppose you go up to a little kid and you say, do you want a cookie or a piece of candy? Okay. Or here means you have this or both. You know, you could be that you did your homework and you cleaned your room and then you get to go out. Okay. But what if you ask this kid, do you want a piece of candy or a piece of gum? Can the kid say both? Yeah. The English in English, that or means one or the other. We actually, and we would say, yeah, do you want a piece of candy or do you want a piece of gum? Do you want one or the other? You can't say both of them. In Java, when you say or, it's okay for there to be both true. In Java, this is actually called the inclusive or. And in English, we use something called the exclusive or. There's actually a technical name for them. Inclusive or means we're including both of them being true. Exclusive or is where you only can have one of them true. So you ask a little kid, do you want a piece of candy or a piece of gum? You're excluding both. You're not letting the kid pick both. You're excluding the case of both. So the kid picks the candy or he picks the gum. He's not allowed to pick both. But we'll say, would you like a piece of candy or do you want a piece of gum? We use the word or. We're using that what programmers call the exclusive or in that case. Whereas the or in Java is what we call the inclusive or. It would let, if I said, do you want a piece of candy or inclusive or piece of gum, the kid could say, oh, I want the candy, or he could say, I want the gum, or he could say, I want both of them. If you're using inclusive or, you're letting the kids say three possible answers. Give me the candy, give me the gum, or give me both of them. But in English, we tend to use the exclusive or. And this actually matters because when you read things in English and you turn them into code, the ors in English have to be quite often treated carefully. If somebody describes something in English to you, and then you have to say, write a program that solves that problem, if there's ors in their English, you may have to be very careful about reading them. Sometimes you have to be careful even about the ands, but you definitely have to be careful about the ors, because the ors in English could be exclusive ors, and then they have to be translated not with this or, but into a little bit something more complicated. Okay, so on the one hand, it's kind of straightforward. And means both, or means one or the other. So and means this has got to be true, and this has got to be true. Okay, and then you do this part. Okay, if one of them is not true, you do the else part. Ors mean, from our point of view, one of these is true. Maybe both of them, but at least one of them is true. If this one's true, then you do what's in here. You don't even have to we'll see if this one's true, you're done. You know that you can go out. You don't even have to check if this is true or not. If you know the person cleaned their room, they can go out. Okay. But on the other hand, if they didn't clean the room, then you say, well, okay, we can check, did you do your homework? Okay. So if the clean room is false, if this one's false, well, okay, then you need to say, well, it's an or. We want one of these to be true. So then we check, did they do the homework? And if that's true, they can go out. Okay. Another thing is, it's interesting, like, suppose you have and. Okay. There's an and here. Clean room is false. What can I now say? clean room, false. And do I know what the case, do I know which way to go at this point?
It'll be else. You can't
It'll
go.
be the, yeah, notice I don't even have to check if they clean, yeah, because and wants both of these. If this one's false, I don't even need to ask, did you do your homework? If clean room is false, you can't go out. That's like, we have a name for that. Actually, that's what the computer does. It's called short circuiting. The computer is real clever. If you write this and the computer sees that this one's false, it doesn't even look at that variable. It will not look at that variable. As soon as it sees this one's false, it jumps down to here. Okay. On your hand, if this one is or, and it's the other way around now. If this one's true, the computer doesn't even bother to look at this one. If this is an or, and this one's true, the computer does not look at this one. We call that short circuiting. The computer is actually a little bit clever. You know, it doesn't do more work than it needs to. If you do an or here, and this one's true, why bother to check that variable? They've met the condition that one of these two is true, so you can go immediately to here. And then for false, the short circuiting works the other way. I mean, for and, when you have and, if the first one is false, then you don't check the second one. If the first one is false, you don't even bother to look at that one. You know that you're over here. Okay. So from our point of view, and means both have to be true, or means that one of them, at least one of them, must be true. We describe that down here using a truth table. This is what we describe this idea using a truth table. When is it true? No, oh, if we go back up here, one thing I didn't mention is that if statements need something that's true or false. So this whole thing becomes either true or false. You check whether this one's true or false. You check if this is true or false. But what you're computing is whether this whole thing is true or false, because that's what if wants to know. Okay. If it's an and this one is false, the whole thing is false. If this is an and this is true, then you go look over here. If it's an and this one's true and this one's false, the whole thing is false. If this one's true, then you look over here. If this one's true, the whole thing is true. Okay? That's what the truth table down here says. We want to know whether the whole thing is true or false. If the first thing is true and the second thing is true, the whole thing is true. If this one's false, it really doesn't matter what this one is, the whole thing is false. If this one's true, well, we really need to know, we need both of them to be true. So if this one's true, we go over here, and if this one's false, then the whole thing is false. Now, they've left a question mark because this was actually a problem here. What goes in the question mark here? If one of them is false, the whole thing is false. And if they're both false, the whole thing is false. So I said, the only thing that makes it true is if both of them are true. Then the result is true. Otherwise, the result is false, false, false. And or is just a little bit different. Real quick. If both of them are true, the whole thing is true. If one of them is true, the whole thing is true. If the other one is true, the whole thing is true. The only thing that makes this false if both of these guys are false. If you go back up here, if you put an or here, when can you not go out? What do you have to do to not go out if it's an or?
Not clean your room or do your homework.
Yeah, you have to make both of those false. You didn't clean your room, you didn't do your homework. You need both of them false to not go out. You can do if you do one of them, you go out. If you don't do either of them, you don't go out. So that shows up in the truth table as this line that says the only way the whole thing is false is if you make both of those false. Otherwise, it's true, true, true. If they're both true, this is the inclusive or. See, it includes both cases here. Okay. When you ask a little kid, do you want cookies or candy? Then true is false because they're not allowed to say I want both the cookies and the candy. So that would be the exclusive or goes true, false. If you ask for both, you don't get it. Yeah, you're not allowed to ask for both. Later on, we'll see what you might do with exclusive or. It's what the English or usually is. More often than not, when people use or in English, they usually mean the exclusive or, but sometimes they mean the inclusive or. So it's a little bit tricky in English. Okay, we ran out of time. We're going to spend, after the exam, well, on Thursday, we'll talk about this a little bit. Then after the exam, we'll be talking about this. We're going to use a lot of logic to write our programs. We're going to be using a lot of, and notice that, you ever heard the phrase, mind your P's and Q's? It's a way, it's a way of saying you're supposed to behave. This is where it comes from. People who talk about logic like to use the letters P and Q. Instead of using X and Y, they use P and Q. So when you're learning logic, you tend to use the variables P and Q, not X and Y. And so you have this phrase, mind your P's and Q's. Okay. So we're going to be doing a lot of this kind of weird thinking about what happens when you do expressions with ands and ors and Boolean variables. Okay, so we run out of time. We'll quit there. If you have questions about the homework's due this evening. If you have any questions about the homework, you can still have time to ask questions about the homework. And then if you have questions about the review problems, if you have any questions about the review problems, send me an email or ask for a meeting. Okay, so we'll meet again on Thursday. I'll go ahead and end the meeting now and see you on Thursday. Bye.